Good morning all. Today we'll see second algorithm for line drawing, that is Bresenham's line drawing algorithm. So yesterday we have seen in the last part for line drawing algorithm, that is DDA line drawing algorithm, some of the drawbacks are there, like a rounding operation is used, and because of that round operation errors are introduced in pixel calculation. Another part is it use floating point arithmetic in the calculation of the pixel positions. So taking these points in mind, we can study for Bresenham's line drawing algorithm to remove these drawbacks. So first, if you see this diagram, figure 1, in that as it is given, the pixel 10, 11 is available and line is passing through number of pixels. Now the question is, which pixel should be selected in this line path? As you can see in this, the line is crossing these two pixels, like 11 11 and 11 12. So out of these two pixels, which pixel should be selected? That is our question. In the figure 2 also we can see, as the pixel is given as a 50 50 50 50, and line is passing through number of pixels, like that is 51 50 and 51 49. So these are the different cases where the line is passing through and line is close to the horizontal axis or vertical axis, or the sign of that particular slope, which you calculate with m is equal to dy by dx. So our question is, which pixel should be selected across this particular scan lines? So for this calculation, we can see this basic general equation, like xk yk is the initial pixel position and line is passing through number of pixels. Slope intercept form of the line is given as y is equal to mx plus b, and in that case, as it cross the pixel positions xk plus 1 yk, and second is xk plus 1 yk plus 1. So section of screen grid showing a pixel in column xk on scan line yk. Scan line is horizontal line, that is the row that is to be plotted along the line path of the line segment with slope 0 is less than m is less than 1. So in that case, ultimately the line is close to the horizontal axis. So this is the situation. So in this figure 4, we can see distances between pixel positions and the line y coordinate at sampling position xk plus 1. So here we can see this is xk yk position. Suppose this is the first pixel and we have to select in xk plus 1 column which pixel should be selected, which scan line pixel should be selected, like either it is in yk or yk plus 1, and original line path is given as y is equal to mx plus b. So distances can be calculated from the center of the pixel position to the line. So this pixel center and the line distance, that is given as a d1, and for this pixel center and the line distance is given as a d2. So these are the distances which are showing from the actual line path to the center of the pixel, in which we have to select the one of the pixel from which line can pass. So in this case, Bresenham's approach, we first consider the scan conversion process for lines with positive slope less than 1. That means the lines which are close to the horizontal or x-axis. So from, as in figure given, like x0 y0 is a starting point, and we step to each successive column x position and plot the pixel whose scan line y value is closest to the line path, as the line is close to the horizontal axis, that is uh, m is less than 1. So in that case we can take the unit increment in x coordinate and relative increment in y coordinate will be calculated. So but this is very much similar, you can find like DD algorithm which you have seen, but in the DD algorithm we have seen the floating point arithmetic is used. Instead of that, integer calculations should be used, and because of that Bresenham's algorithm is available. So in figure 3 we have demonstrated the kth step in this process, assuming we have determined that the pixel at x, k, y, k is to be displayed. We next need to decide which pixel to plot in column xk plus 1. So either it is position yk or yk plus 1. So our choices are for the pixel position xk plus 1 comma yk and xk plus 1 comma yk plus 1. So as we can see this in this particular figure, this one, either it is xk plus 1 yk, this pixel, or here you can see, or this is xk plus 1 yk plus 1. So at sampling position xk plus 1, we label vertical pixel separations from the mathematical line path as d1 and d2. As we have seen, these are the distances of the pixel centers from the actual line path. So for this, the y coordinate on the mathematical line at pixel column position xk plus 1 is calculated as y is equal to mxk plus 1 plus b. So as our basic equation in the line slope intercept form for the line, that is y is equal to mx plus b, that is intercept. So here the column xk plus 1 is available, so we are putting instead of x, xk plus 1 column value. So then d1 can become y minus yk, and putting the value of y in this equation, we will find this equation number 2, and d2 will become yk plus 1 minus y. So again going back to this particular diagram, we can see here this is the equation, the line equation y, which is satisfied by this particular line, y is equal to mx plus c. So d1 is nothing but y minus yk, and this is d2 is equal to yk plus 1 minus y. So this is d2 and this is d1. So this is given with the help of equations. So d2 is given as yk plus 1 minus y, and giving the value of y in this equation, putting this value, we will get this equation number 3. So the difference between these two separation is given as, say, as we are individually calculating d1 and d2 by giving the equation of slope intercept form, basic form of the line, and then finding difference between these two distances. So calculating, we will find this equation d1 minus d2 is equal to 2m xk plus 1 minus 2yk plus 2b minus 1, and that is equation number 4. So now we'll introduce new term. This is called as a decision parameter pk for the kth step in the line algorithm, and can be determined by rearranging equation number 4 so that it involves only integer calculations. We accomplish this by substituting value of m. So in this case, as we can see here, the value of m, that is the slope, is introduced, or this term is available, and in this term slope is nothing but m is equal to dy by dx, or delta y divided by delta x, and this is fractional value, or it produces some floating point arithmetic. To avoid this floating point arithmetic value, and just to convert it into only with integer calculations, we can put m is equal to delta y divided by delta x, or removing that, multiplying both of the side with delta x. So we'll find delta x into d1 minus d2. So here uh, denominator part will be cancelled. So that is done here. M is equal to delta y divided by delta x, and pk, decision parameter term, is equal to delta x into d1 minus d2. So difference of these two distances is multiplied with delta x to cancel the denominator term, and ultimately reducing the calculations in the floating point form and converting that floating point arithmetic to the integer arithmetic. So multiplying with delta x to this term, we will find this equation 2 delta y into xk minus 2 delta x into yk plus c. So sign of pk is the same as the sign of d1 minus d2. Now in this equation we can find this is the value of decision parameter, and the sign of decision parameter is depending upon the sign of this particular difference d1 minus d2. So we can see now d1, if d1 is greater than d2, so meaning of this is d1 is greater than d2 means, again we'll go back to this figure. If d1 is greater than d2, that means this distance is less than this distance, and this pixel is close to the line path than this particular pixel. So we'll select this particular pixel if d1 is greater than d2. In another way, if in second case, if d2 is greater than d1, in that case this pixel position is close to the actual line path than this pixel, so we'll select this pixel. And d1 minus d2, if d1 is greater, it will produce positive value, so decision parameter pk value will be again positive. If d1 is less than d2, then the difference will produce negative value, and pk, that is decision parameter value, will be again negative. So the decision parameter value is depending upon decision parameter, sign of the decision parameter is depending upon this difference d1 minus d2 calculation. So if the pixel at yk is closer to the line path than the pixel at yk plus 1, that is d1 is less than d2, then decision parameter pk is negative, and in that case we plot lower pixel, otherwise we'll plot upper pixel. So it is depending which pixel should be selected. We can take this decision based on this value, not only value but sign of the decision parameter. If the decision parameter is negative, that means d1 minus d2 is negative, and in which case it is negative if d1 is less than d2, and if d1 is less than d2, that means the pixel with lower value, that is lower means closest pixel, is available in the yk xk plus 1 yk, otherwise it is xk plus 1 yk plus 1. So coordinate changes along the line occur in unit step in either the x or y directions. Therefore we can obtain the values of successive decision parameters using incremental integer calculation. As we have seen, the line is close to the horizontal axis, so we'll increment by 1 in x coordinate. If it is close to y axis, then we'll increment in the unit increment in the y axis or y coordinate, and relative increment in x will be calculated. But in this case, as we are considering line is close to the x axis, unit increment in x will be done, and relative increment in y we are calculating. Either again relative increment is in terms of unit, either it is 1 or 0. That means in the same scan line we'll have another pixel, or in the next scan line we'll have another pixel. So at step k plus 1, the decision parameter, so for that successive value of decision parameter should be calculated. So at step k plus 1, the decision parameter is evaluated from earlier equation by putting k is equal to k plus 1 in earlier equation. So in earlier equation, instead of k we are putting k plus 1 and finding this equation number 6. So now subtracting equation 5 from 6, so we'll get pk plus 1 minus pk, and we'll get this particular equation. So in this case, reducing that calculation to this form, 2 delta y in bracket xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. But as the line is close to the horizontal axis, xk plus 1 is equal to xk plus 1. That means xk plus 1 minus xk, this term will be 1. And so it will be reduced, and rearranging this equation will get pk plus 1 equal to pk plus 2 delta y, and this is 1 minus 2 delta x yk plus 1 minus yk, where the term yk plus 1 minus yk is either 0 or 1 depending on the sign of parameter pk. So if the sign of parameter is again depending upon difference between two distances, that is d1 minus d2. So if d1 is greater, then yk plus 1 minus yk will produce 0, and if d1 is greater than d2, then this difference will be 1. So this recursive calculation of decision parameter is performed at each integer x position starting at the left coordinate endpoint of the line. So the first parameter p0 is evaluated from equation 5 at starting pixel position x0, y0, and with m evaluated, that is slope, as delta y divided by delta x. p0 is equal to 2 delta y minus delta x. We can summarize the Bresenham's line drawing algorithm with positive slope less than 1 in the following listed steps. The constants, as the increment is done in this form, you can see this. See, pk plus 1 is equal to pk plus 2 delta y minus 2 delta x, and yk plus 1 minus yk, this is either 1 or 0. So increment is done in terms of, if it is 1, then the increment in earlier decision parameter we are incrementing by 2 delta y minus 2 delta x. If it is 0, then only we are having the increment of 2 delta y in earlier decision parameter. So algorithm summarize steps for Bresenham's line drawing algorithm. Input the two line endpoints and store the left endpoint in x0, y0. Load x0, y0 into the frame buffer, that is plot the first point. Then calculate the constants delta x, delta y, 2 delta y, and 2 delta y minus 2 delta x, and obtain the starting value for the decision parameter as p0 is equal to 2 delta y minus delta x, as it is given initial value of the decision parameter. At each xk along the line starting at k equal to 0, perform the following test. Now based on the first value of this particular decision parameter and what is the sign of this decision parameter, we are taking the decision on successive pixels. So if pk is less than 0, the next point to plot is xk plus 1 comma yk, and pk plus 1 is equal to pk plus 2 delta y, because yk plus 1 minus yk is equal to 0. We are not going to next scan line. In that scan line only we are going to select the pixel. So on second term becomes 0 here, only increment of 2 delta y in the successive decision parameter calculation. Otherwise the next point to plot is xk plus 1 comma yk plus 1, and pk plus 1 is equal to pk plus 2 delta y minus 2 delta x, and repeat this step up to delta x times. That is number of steps which we have to, because we are line is close to the x-axis, so we are having unit increment in the x value. So from starting x coordinate to the last end point, x coordinate. We are continuing up to this point with unit increment, so it is continued up to delta x times. So this is the Bresenham's line drawing algorithm, which reduce the calculations. Floating point arithmetic is totally removed. Only integer calculations are available. Then error is not introduced in this because of round off error, which was available in the DD algorithm. So this is about the Bresenham's line drawing algorithm.